In example 2 and example 3, we're going to practice using the formula. So let's start with example 2. We have a solar panel manufacturer that analyzes energy output from its panels. The average energy output in a month is 425 kilowatt hours, with the standard deviation of 52 kilowatt hours. If a specific panel had a z-score of 2.75, how much energy did it produce that month? We're going to round to the nearest whole number. So we're going to make a graph. I'm going to put my x's and then my z's. So for my x's, that's the data, the raw data that's directly related to the content, so our kilowatt hours. So it tells us that the average is 425 kilowatt hours, so I'm going to put that in the middle. Now, if I come out one standard deviation, I have to add 52 to 425, and that's going to give me 477. If I add another standard deviation, that gives me 529. And then when I come out again, one more standard deviation, that gives me 581. Now, going in the other direction, I would have to subtract. So I'm going to take 425 and I'm going to subtract 52. So that's going to give me, let's see, 373. And then when I subtract 52 again, that gives me 321. And then one more time, that gives me 269. So these are my data values that correspond to the content of the question. Now, if we want to standardize this so that we're only looking at how far out in terms of standard deviations we're coming out, the center would be 0. Then 477 would be one standard deviation out, so that would be z is equal to 1. 529 would be z is equal to 2, because that's 2 standard deviations out. 581 would be equal to 3, because that's 3 standard deviations out. And then we're going to do the same thing in the other direction, but they're just going to be negative. All right, now the question says, if we had a z-score of 275, how much energy did it produce that month? So this represents the energy in kilowatt hours. This is our z-scores. So we're looking for a z-score of 2.75. So somewhere in here, right? Somewhere in here is z is equal to 2.75. So I expect my x value to be somewhere between 529 and 581. Somewhere between here. Now, we can't just eyeball that from the table, and that's where the formula comes in. We have z is equal to x minus mu over the standard deviation. When we're looking for the x value, we can rearrange that equation and write it like this. So I'm going to use this version since we're looking for x. I'm going to take my value of z, which is 2.75, and I'm going to multiply it by my standard deviation, which is 52, and then I'm going to add my mean, which is 425. When I do that, I'm going to get 568 kilowatt hours. Now, when I look at that, it makes sense with the graph because I know that it should have come out somewhere between 529 and 581. So if I, for example, came out with something like 490, I know that there was an error somewhere because it needs to fall in between these two values. Let's look at example 3. A coastal city tracks the wave height index, which ranges from 10 to 35 for moderate surf. The average wave height index in Seabreeze is 18 with a standard deviation of 6. On a particular stormy day, the wave height index reached was 36.8. We need to find the z-score for this wave height and round to 2 decimal places. All right, let's draw the graph. That's pretty bad. I'm going to redraw that. Okay, it says the mean is 18, so that's going to go in the middle. The standard deviation is 6, so I'm going to add 6 to get my first standard deviation, so that's going to give me 24. When I add 6 again, that's going to give me 30. And then when I add 6 again, that's going to give me 36. Now going in the other direction, I'm going to take 18 minus 6, which is 12. Then minus 6 again, which is 6. And then minus 6 again, which is 0. So these are the x's. This is the data that corresponds to the content of the question. Now when we standardize this, as usual, it's going to be the same every time. 0's in the center, and then it comes out 1, 2, 3. And then on this side, it's -1, -2, -3. We need to find the z-score for this wave height, meaning 36.48. So we are given the x value, which is, let's see, a little bit past 36 right here. So when I calculate my value of z, it should be a little bit over 3. So my z value is the data value minus the mu divided by the standard deviation. I'm going to put in my value for x, which is 36.48. I'm going to subtract the mean, which is 18, and then I'm going to divide by the standard deviation, which is 6. When we do this, we get that z is equal to 3.08. And that makes sense with the graph because it's a little bit past 3 on my z's when it's a little bit past 36 on my x's.